Hey everybody, we're going to be starting Unit 5, Linear Models and Systems for this upcoming probably 3 weeks. This stuff is all information that you have learned in Algebra 1 before, so I'm going to go through it relatively quick. But as I go through each of these problems, make sure that you are taking notes, rewinding it, not rewinding, dragging your little scroll bar back to the beginning, starting back over, anything that you need. If for some reason these examples aren't good enough for you or you need more, in the description box below, I am going to have an extra link to another video with me talking through it again that will have more examples. So I'm going to have randomized things, just what do you do if you need to combine like terms? What do you do if you have a variable on both sides? How do you fix that? Etc. So make sure you check the description box below if you are confused at all during this video, and going back to the beginning and starting over doesn't help. So what we're going to look at first is just kind of the big idea. Today specifically we are going to look at 1 and 2 variable linear systems. Remember the word linear, we've talked about that before. Linear, if you chop off that AR, so if you cover this AR up, it says line. So think of that as in a graph as creating a line, which means it is constant. It is very consistent in how it progresses, either up or down. And the big idea is that all of this can be applied to real world situation. Pretty much any situation you look at in the real world can be basically chunked down into this mathematical equation. Some of them really complicated, some of them really simple. We're going to stick to the simple stuff for now. Keep it linear. So we're going to look at 1 and 2 variable. Think as a variable as, an x, a y, a z. Those are the most common things. So let's look at this example that we have here. This is the most basic version that you will ever see, ever, ever, ever. So this is an equation. An equal sign in the middle just means it's an equation. And it says if 2x equals 8, what is x? So you're solving for the variable x. In order to figure that out, you need to get x by itself. First step, you have to know what in the world is happening to x right now. Well, there's a 2 attached to it. It's glued together. You don't see a symbol between the 2 and the x. It's a sneaky multiplication sign. It doesn't like to show itself. So it's actually 2 multiplied by x equals 8. And most of you can look at this and go, Miss Jose, my goodness, I know exactly what it is. It's obviously 4. That's great. I'm glad that you can see that. But do you know how you would have pulled this apart if I gave you kind of a weirder number there? What if I gave you a fraction? Would you have known? Fractions aren't scary. So we're going to look at this and actually pull it apart. So we have 2 times x, and we want to get x by itself, which means we have to get rid of the 2. X doesn't want to hang out with the 2 anymore. We need to separate them. They're glued together with multiplication right now. What is the opposite should be the question you ask yourself. Anytime you are trying to get a variable alone, think, what is the opposite? Well, instead of 2 times x, the opposite would be dividing. So we are going to divide by the number we want to get rid of. We want to get rid of that 2, push it aside, say, hey, we don't want you over here anymore. Go join the 8. So the x is going to be divided by 2. And it'll look like this. So this is how I'm going to break down my steps from here on out. I'm going to try and list out step by step. And then on the right hand side over here, I'm going to have what in the world I did. So 2x divided by 2 gets us 1x. 2 divided by 2 is 1, and the x just kind of still hangs out there. You have to do that on the other side as well. That equal sign means it's kind of like a scale. If you do something to one side and one side only, your scale no longer matches up. You need to make it equal. So we had to divide by 2 on the other side as well to keep it level. So 8 divided by 2 gets us 4. And then I just rewrote it as x equals 4 because 1x is the same as x. It's like saying you have 1 xylophone or 1 panda or 1 bouncy ball or 1 water bottle. So there's really no reason to say you have one of it if you just said, I have a panda, I have a xylophone, I have a water bottle. It's the same concept. So the 1 over here is not actually needed. So I just rewrote it as x is 4 or x equals 4. And you're solved. So that's the most basic concept. If I say solve for X, solve for B, solve for T. That means get that variable alone. So let's look at this concept here. This is going to come in handy when you're working with more steps. So the previous equation we looked at was a one-step equation, which means you only had to do one thing to it in order to solve. Anything requiring more than one step, you're going to want to know this acronym, which most of you already know, PEMDAS. So that just stands for parentheses, exponents, multiplication and division, addition and subtraction. So that just tells you the order and how to solve something. So if I gave you that equation up there, you would know you had to do multiplication before you would do any addition steps. When you are solving, when you are trying to separate pieces from each other, you actually have to do the opposite. So I actually have a little visual demonstration here. If you're like, Miss Jose, I know how to do this, skip this little paper piece. So whenever you see this little Pac-Man on the screen, you can go ahead and skip that if you already know why it is you have to undo something. So right now, I kind of created a paper origami, whatever, Pac-Man. And it took probably about 12 steps in order to get him together. And if I want to get him back to his standard paper size without ripping him in any way, shape, or form, I have to undo him the exact same way that I put him together. Same concept with equations. Right now, you'll see kind of on the back there are these folded pieces. I can't just grab that and try and pull it apart because it's not going to work. This is all together. Can't do that without ripping him. So I can't just pull from the middle and hope to get back to the beginning. Same thing with an equation. Right now, I'm going to actually walk you through kind of the steps on how I did it, but I'm doing it backwards. So in order to get him back to his standard sheet size, I got to back it up. So we're going to pull kind of his tongue out first, and he gets folded into this square, sort of. And then I have to fold him together a little bit more in order to get back to his triangle form. And then I have to fold him down in order to get back to square form. Oops, see, I've already made an error. See, this shouldn't be folded here. See if I can back him up a little bit more. All right, I fixed it. Sorry, didn't want you to watch that. So I'm back in triangle form. Can't have errors like that. Fold him down to get back into square. And then I have to pop this out yet again to get a triangle. Oop, too close. Then I have to fold it down again to get yet another square and pop them back out to get kind of this like sailor hat. So it is a triangle, but it is a sailor hat as well because you can open it up, put it on your head. So I'm going to take this apart even further. I had some more folded up pieces that I need to fold back down. And I get this, which I can then unfold. So I'm at half a sheet and then unfold again to get back to the beginning. So I got it back to the start, and the only way that I could do that is by removing it completely backwards. So whatever I ended with, I had to start with. Whatever I started with is what I ended with. Same thing with equations. So if we look at this one here, I have 5x plus 3 equals 13. I need to know what is x. Well, we've got 5 times x plus 3. In order of operations, it would tell us to multiply first and then add second, but we're ungluing this. Remember, we want to get x by itself, and we need to reverse process. So instead of multiply first, add second, we are going to get rid of that plus 3 first, and then get rid of that multiply by 5 second. So to get rid of a plus 3, that 5x is like, get out of here, 3, we don't want you anymore. So to get rid of it, think again, what do I have to do to undo that? Well, to get rid of a plus 3, the opposite is to subtract 3. So if I subtract 3 from both sides, 5x is the only thing left on the left-hand side, and 10 is what is left on the right-hand side. 13 minus 3 is 10, 3 minus 3 is 0, so it's gone. Then we can do just what we did in the very first equation. We have 5x equals 10. Well, the x is like, get out of here, 5. So in order to get rid of the 5, we have to do the opposite. So instead of multiplying, we are going to divide. So if we divide by 5 on both sides, you get your answer, x equals 5. Okay? So let's look at an example where we have two variables. So a two variable equation, it can be any letters at all. This one specifically tells us to figure out what is y when x equals 9. So it's giving us a value of x. So first thing you're going to want to do is substitute, just like a teacher can substitute for me. So if I'm gone, someone else will take my place. If x is gone, 9 can take its place. So we have 4 times 9 in there instead. Well, 4 times 9 is 36. So that's the only thing I've done thus far. We have 36 plus 6y equals 42. Do the exact same thing we did on the previous slide. So we have this 36 over here that's being added. Well, let's get rid of that. So instead of a positive 36, subtract it. That 6y is like, get out of here, 36. So if we subtract 36 from both sides, we get 6y equals 6. Then we want to get rid of this 6. So the y wants to be completely alone, so the 6 needs to vanish. Instead of 6 times y, we are going to divide by 6, in which case you get 1. So when I give you x, you can find y. Ooh, gave away an answer already. So in this one, it says 4x plus 7y equals 42, and I say solve for y. Notice now, though, how I did not give you x. You still need to solve for y. Well, in this case, over here, just like earlier, that used to be a 36 because I gave you a value and we were able to subtract it from both sides. You can do that here with a variable. So the 4x, we want that gone. It's being added to 7y, so let's subtract it. If we subtract 4x from each side, it just vanishes over here, leaving us with just the 7y, and then the minus 4x just appears on the right-hand side. Simple. So the only thing we have to get rid of now is that 7. The y does not want the 7 by it anymore. So instead of 7 times y, we are going to divide by 7 on both sides. And you get your answer. It looks kind of ugly. It can be simplified a little bit here and there, but that's your kind of general idea for how to move stuff around. So that 4 and the x just moved as a whole from one side to the other, and then we got rid of the 7. Last one we're going to look at is parentheses. So I'm giving you two variables here, the variable r and the variable m, and I want you to get m by itself. But notice how the m is kind of encapsulated inside those parentheses, which means we can't get to it yet. We have to get rid of this negative 5r first. Well, right now it's being multiplied. So parentheses are like secret multiplication. If there's nothing in between that number or variable in the front in the parentheses set, it is being multiplied. So instead of multiplying by negative 5r to get rid of it, let's divide. So if I divide by negative 5r on both sides, this is what it looks like. So the m plus 3 stay, and you don't need the parentheses anymore because there's nothing outside of it. And then the negative 5r got divided. Well, this can actually be simplified into something nicer. I know you guys don't like fractions. So 15 divided by negative 5r, well, think what's 15 divided by negative 5? That should get you negative 3. So I just simplified my fraction here in order to get negative 3r nicer to work with. So then your last step, let's look back over here. We want to get m by itself. So instead of adding 3 to m, in order to get rid of it, say goodbye, positive 3, we need to do the opposite, subtract 3 on both sides. So we have the m by itself now, the negative 3r, subtract 3. And that would be your answer. Even though it has a variable in it, it would be your final answer. So that is kind of a quick run through on everything that you're going to see. I did not cover how to combine like terms or what happens if you have variables on both sides that are the same. But if you can do these steps, you should be able to do those as well. Just kind of push yourself to try it. I'm going to include kind of a link below that will lead you to any other video assistance and for some problems for you to try before you come in tomorrow. Okay? Good luck.